Fasten your seat belts. Lightning talks, 5 minutes each. Rapid succession. We're all set. Ready, set, go. Tim Zöller.
You can hear me? You can read the code? Thank you. So I'm going to talk about integration testing. It's live coding without slides, and I had the idea when I saw the Lightning Talk poster this morning, so what can go wrong? We want to do integration tests, right? And we want to do integration tests as the real deal. So if we want to test against, if we are using a Postgres database in production, we want to run the tests against that database, not some in-memory substitute. This means we need infrastructure for integration testing. For example, the database. We check out the code and we run the test, but we need access to some kind of database. Everything that we have to set up manually is possibly a hassle. It makes onboarding harder. So the Java guys in the Java world built something really great, and it's called test containers. And they decided to attach Docker containers with the right configuration to the test lifecycle. This is a nice idea and made a very big splash in the Java world. And as I'm working kind of with Java in my professional life, I thought, okay, why not use this in Clojure? But it's Java code, and we don't want to use Java interop. Or I don't want that. I don't know about you. So I decided to build a wrapper library. And here we have a unit test with, or an integration test with dev test. We are testing, we are creating some values here, and we test db/createUser, which probably stores a user in the DB. And we say if the UUID of db get by user ID via email is the same, then we have proven that we stored the user into the database, we loaded it again, and the data is as expected. So how to set up the database? We have the CLJ test containers library referenced here, and we are using a test fixture. We are creating a container. We define our container by data. Not like Java interop, we have to call setters and builder patterns. We don't want that. We don't do that here. We have created a map which defines the behavior of our container. It's a PostgreSQL container with version 12.2. We expose port 5432, initialize the thing and start. We can see later why that's two calls of two functions. And then we map this into our mount config. So the application uses mount. We set the password, username, JDBC URL, and we start that. Okay, let's do an integration test. On the right hand here is a terminal which shows Docker PS every second. So now the test initializes. I guess it checks if the container exists. I hope I downloaded it up front. And here we see that the PostgreSQL container is there. It was initialized. Here is some container left. And everything worked without me having to set up anything manually. And now you might say, but Tim, we still need the database locally because we want to develop locally. And the fun thing is we can use test containers in the REPL also. So we have the user CLJ in the env dev folder. And we are creating, if we say REPL start, we pull up the container. We map everything into mount. So going back, line REPL. While it loads, visit our GitHub. We put some thought into the documentation, and there is a lot of documentation. If you want to commit something and help us, that's really appreciated. And now we say REPL start. We're starting the application. Again, we see some logging when the container is booted, which usually goes faster, but I'm not sure why it's so slow this time. And now we see that the Postgres container is running. There is the Ryuk container running. Thank you. And yeah, we could now use our application. Because when we started the application state, we created the test container along with it. We don't need any prior setup. We are doing this also in our application for one XTDB environment, so it's not only limited to databases. You can use queues, broker, whatever you like. And the last question is, what does this Ryuk container here do? That's a nifty thing that the test containers Java guys figured out for them. This is a keep alive service. If Ryuk communicates with the JVM that started the process, and if the JVM terminates, it realizes that and tears the whole Docker setup down again so we don't pollute our local Docker environment. Again, I'm standing on the shoulders of giants here. I did not create test containers itself. It's just a Clojure wrapper. I encourage you to figure this out, to give it a try. Thank you very much. Have a great evening.
That was perfect to the second. Awesome. Okay, next talk. Andrea Amantini, take it.
Do I need to talk here? Yes. Hello. I'm going to show you some kind of example of a Clerk notebook. So, Clerk is a library, is a set of tools that lets you turn your Clojure namespace into a notebook, so into a live web application, like more or less like this. And it also ships with a layer of composable viewers that allows you to inspect your data mostly like this. So in this example, I kind of wire an OSC touch application from my phone. You should see this feedback here. And this is OSC is a nice binary protocol over UDP for usually connecting synthesizers and multimedia devices, but I use it here to modify the parameters of my simple model here, and this actually influences the behavior of my animation here. So I can actually change the amplitude and the frequency of these three components, and and this is what you see here. So the result is a curve, a function of time on the plane. Yeah. So as you change stuff here, you can modify this and this, more red, more green, less red. And for the harmonic analysis freaks, you have also a wave mode that sounds like this. And then you can go back to your Spirograph stuff and clean. So this is this is more or less it. The formula should be correct, and this is the function that renders it. It's in a quoted form because it lives next to your Clojure code. It lives on the JVM, and Clerk is responsible for syncing your Java process state with the reagent state on the other end. So here it follows some machinery to actually turn an OSC message into a Clojure map, and then some stuff to update the model and recompute the notebook programmatically. And this is the piece of Java code for getting the Java, more or less, but to get the OSC server listening to incoming messages. And there's also the syncing in the other direction. This is to sync back. I think. Do you still see this? Yeah. So Clerk workflow is nothing different than your REPL actually. So you can still go inspect your model back at the REPL and save it for later reuse. Yeah, or do say minor adjustments of the parameters, and it's still it's what you already know. Yeah, and that's it. Yeah. Thank you.
Excellent, thank you. Next speaker, Malcolm, please.
Alex hasn't received any instruction for what I'm going to ask him to do, but we're going to talk about the 6 degrees of separation. This is Alex Davis, I'm Malcolm Sparks, and we're both developers at Juxt. So this is called the 6 degrees of separation. Now, we like to use a mental model of complexity in Juxt. We want to find out where complexity comes from. It's a really dangerous, horrible thing. And as Clojure developers, we love simplicity. So I'm going to ask Alex to point out the first degree of separation, which is between code and data. You've got to point at code and data at the, yeah, so code is at the bottom. Now we understand what code and data is. This is what makes us functional programmers, by the way. If we put code and data together, what do we get? Object orientation. We don't like that at all. The next degree of separation is time and data. We know that time is a very interesting and dangerous concern. If you don't tackle it, it will tackle you. And we like to model time as a very important domain in our programs. So one of the things that we try to do in the epochal state idea of kind of keeping state is around keeping data and time separate. We've got tools like this in X2DB and Datomic that allows you to have an immutable log of events so that you can control time. The next one I want to talk about is data and form. This is, if you keep these two in lockstep. Now, we talk about these forces, these 4 individual things that have 4 letters, and there's 4 of them. The reason we talk about this is because they evolve into different rates. So time is eternal, data is forever, form evolves. By form, we mean kind of your domain, and code is fleeting. So if you keep these things in lockstep, then one of them is unnaturally evolving at the wrong rate. Code and form. So data and form is really about if you prematurely decide about your domain, your types, your schema with your data, then you end up having to do expensive data migrations. Form is just your interpretation of your domain, and our interpretation of our domain completely changes as we understand our domain and as our domain changes. So we like to talk about things like schema on read rather than schema on write. If you've heard those concepts, that we're really into schema on write and being able to layer on an interpretation with data. Don't define them together. Code and form. Alex, can you point out code and form? Form needs to be independent of your code, right? There are so many programmers today that are encoding into their programs domain types. If you've ever done in Java public class customer, public class product, you'll know what I mean. And I think this is a real challenge for us. We need to stop coding form into our programs, because when the form changes, as it will always do, what do we have to do then? We have to change our code. And then we need developers to change our code. It's like having a car. You're driving a car and it doesn't work, and you have to get out and you push your car, and you need other developers to push your car along the journey. And you realize that everybody else driving a car is pushing their cars. And sooner or later, you're going to run out of developers to push cars. And you can come up with wonderful, fancy phrases like continuous pushing for this, and come up with tools like boots and gloves. But ultimately, you're going to wonder, why doesn't the car begin to push itself? And surely that is a better solution. So the next one is time and form. When we change our schema and do data migrations, if we talk about data being kind of update in place, what about schema and form? Aren't we just simply replacing one schema with another? We've lost the old schema. I think this is a really interesting research project to keep our schema and our interpretation onto our timeline, into our temporal databases. And then finally, how much time have we got left? 1 minute left. So this is the 6th degree of separation, is time and code. Remember when code, did anyone work on projects where you didn't have version control? How did that work out for you? It wasn't great. It was horrible. So we understand, the developers understand why it's important to have a separation between time and code, don't we? And I think an interesting research project is actually putting more of our code into databases onto the timeline. So I can't talk more about that because this is a lightning talk and we're out of time. But thank you very much.
Okay, short applause for Philippa. And here we go.
So yeah, I'm Philippa. Hi. I'm one of the makers of Clerk, and Andrea already shortly introduced Clerk, so I want to continue there. So one of the nicer things that you can do to your Clerk dev workflow is like assign a key binding to your editor that lets you eval your current namespace and basically reevaluate your Clerk document. So the feedback loop on this is quite fast because we do a bunch of caching for all the results. And this is especially useful if you build UIs. So this namespace, I just want to demo this really quick. So you have a comment here that is rendered as markdown on the other side. So I want to change this to oh hi and rerun the document, and it changes almost immediately. So for a UI dev workflow, this is especially useful. So if any of you are familiar with dev cards, with dev cards you usually change a file, then you have to wait for a file system event. When this file system event comes, your browser is being kind of like refreshed, and then you see the changes to your UI. So what I can have here, and this is also the workflow that we use at our company, is I may have a Clojure namespace that has a bunch of comments in there, and that it's like for a super secret project that just consumes a bunch of file names, and it goes over these file names and creates some state from it. And it processes the state along the way and adds stuff to it, removes stuff from it. And it's basically some backend person may have developed this, and as a front-end person, I might get this and want to build a UI for this. So the way you do this in Clerk is, let me just run this namespace here. The way I do this is I may add a bunch of components. Sorry, let me show this here. I may add a bunch of components that are just normal reagent components. So you have like status light here. It's just hiccup code that consumes state. I may have a spinner, I may have a check mark, and so on and so forth. And one of Clerk's superpowers is that it has a built-in viewer that's called HTML that just lets you render reagent components. And I can assign this to any of the data that was passed to me in this document, and assign this viewer to it and let it render out. So if I can look at this here, so I'm just taking the initial state, I'm assigning it a custom viewer that's called batch viewer that essentially just renders out this reagent component, and then I see how this looks like here. And as the document progresses, as the state progresses, there's always the same viewer assigned, and I see kind of like how the UI changes along the way. So here the document was parsed, and I see that there's like 19 code blocks. Then the document is analyzed, and I see, oh, there's actually a bunch of like code cells in there, and then it goes on. So the document may have like it's being processed or executed, and I get like more state, and I want to visualize the state here. So I'm building my UI along the state that's already in the document. Yeah, and what's cool about this is like the data that I'm acting on, like here, is actually never being touched. So I'm just assigning this metadata. So in the end, hopefully, I end up with a namespace that contains like all the actual API, like the backend API, the front end, and the documentation. And I'm all getting this as a single notebook that I can reuse in other namespaces. So that's pretty much it. Thank you.
Another round of applause for Michael.
So, I come from an interesting background, which is not Clojure, at a Clojure conference. And I want to talk about kind of my last project, which was mostly in Ruby and Haskell. Leveraging things I've learned from functional programming to untangle legacy code. So we have this legacy code, and we all hate the legacy code, but the cool thing about legacy code is it tends to be legacy code because it makes us money and allows us to have jobs. So I think we should all take a moment and really enjoy the freedom that legacy code gives us. The problem is when we actually have to drive the legacy code, it doesn't look so much like this, it looks more like this. And so what are you supposed to do with that? It's rusty, it's complected, whatever that means. Yesterday I went to fly a kite with my colleagues who are all in Berlin, and I made this happen to the kind of strings that fly the kite. And this is somehow what it feels like to work with legacy code, except like 100 times as big, because it's had 10 years of people adding more functionality, and rarely do people have the time or the understanding to kind of untangle the code. So I saw this great talk by Michael Sperber, who runs BobConf, and about how he teaches software development, and I want to teach you something that probably you know, but he basically was like, well, we teach software development, and there's some people, they think they're really smart, and they're like the star students, and then the computer science professors, they feel like, oh, because there's some people that are really smart that learn how to write software, I'm a good professor. But really, we're not all like, Einstein's here or whatever. We're like normal people. I know we might have a different perception of ourselves, but here's an approach that you can take using functional techniques, which is like just a regular way that, similar to the technique used to untangle this knot, is just kind of pulling the string out at the end and then just doing it again and 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 doing it again. We can use similar techniques in borrowing from functional programming to untangle legacy code in a safe way, in a way that you can show your colleagues of any kind of different skill sets, and you can end up with code that people can understand. So I need to jump forward. So I have a very arbitrary, a very simple, contrived example. So usually what we have with legacy code is we have a lot of simple code nested on top of a lot of simple code, nested on top of a lot of simple code, and then you have leaves. And the leaves of your code you can kind of manipulate, and then up one level you're stuck. And the question is, how can you push the things in the leaves of your code up a level? I want to change a function, but it's doing something nested that I don't expect. And in functional programming language, we have a term for kind of code that is not doing something expected in a deeply nested way, and that's called pure code. So let's try to make pure code from our legacy code, which tends to have a number of hidden side effects. So we have our very simple. Let's make this much bigger. I am almost blind. So we have a simple question. I used to work at an educational company, and we would do a lot of answering of questions. And here's my contrived example. Excuse my Clojure, I don't know what I'm doing. We call it a function called answer question, and it's going to excuse me. Oh no. I'm giving up. I'm just going to go without slides then. What I want you to do is I want you to take I want you to find your side effects in your code. I want you to copy the side effects, and I want you to paste them in the parent function. I want you to inline without remorse. I want you to inline as much code as you want. I want you to duplicate as much code as you can, such that you can no longer have a deep nested stack, but you have a tremendous amount of inline code, and then you can see exactly where all your side effects are. And subsequently, you can actually make some sense of what's happening. And I think that's all I have right now, because I lost my example code. Yeah, thank you. Sorry.
Thanks a lot, Michael. Can we have one extra round of applause for very good improvisation talent, please? Cool, and the last one. Renzo? Oh, there you are.
All right, I'm going to try something difficult. So let's say we think functionally, but at the end of the journey, we run imperatively. Like when you go down to the CPU, you're talking registers, you're doing jumps, you're doing stuff like that. That's very interesting, but we work in an abstract language. It doesn't have any of that. Luckily for us, right? We don't work in assembly all the day. There's no recursions down there. There's no closures. There's no even functions. So how is this possible? This is my question. Let's go by steps. Here's a simple function. It's summing 10 numbers, 1 to 10. It's making 55. Very good. And this is just the same like before. I'm just printing the operands so you can see what's happening step by step. There's a little bit of dot, 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 but it's summing up. You can see the partial 1 plus 0, 2 plus 1, and so on. So all good. So let's use a large value for n, and we go. You can actually see better like this. Sorry, and let's use a large value for n, and we see that of course we're going Stack Overflow, and that's why, because we're not using recur, right? So we know we need to use recur. Just we put our recur, and we can only recur from tail position. Right? That's something that you might have seen once in a while. How? What do we do? So we have a few things we can do. One of them is change the algorithm to make it tail recursive. So you know this trick. Sometimes you can do it, sometimes you don't, depending on the complexity of the function. You add the accumulator to the parameters that you are bringing on every iteration, and so you can move the last step that was not tail recursive inside the tail of the function, and there you have it. You have your tail recursive function. But is it? I mean, it is definitely tail recursive, but is it exactly the same? So let's print again the operands. And if we print them again, you can see that now something is printing differently. You're starting from the bottom or from the top of like your list of parameters, so starting from 10, summing then 9, summing 8, and going down to 0, which at the end is the same result. Fine, but you're lucky because plus is associative and commutative. So you change the function. In this case, you're lucky, but you're not always allowed to do this, especially if plus is having side effects and stuff like that. You're reversing them. All right, progress so far. We attempted to get rid of recursion. It's tail recursive. And tail recursion can be treated as an imperative for loops. We saw that with recur. We can't always go tail recursive. Sometimes we can. Sometimes we can't eliminate tail recursion. Or is it that we cannot always eliminate tail recursion? Well, let's see. Let's do a little bit more refactoring in baby steps. Introducing a parameter for a callback function. I'm introducing an identity thing. I'm pushing it down the function. It's called cont. It's not by coincidence, but it's a function. And I'm not doing anything with that. I'm just bringing identity around, not using it. But I can push it even farther down the if branches, and you can see now cont. I can call it on 0. I can call it on the results of the function. I can also introduce a wrapping lambda. You can see that there's an equivalence there. F is the same as, I cannot point it out correctly, but it's a lightning talk. You can count to me, and we'll watch this like 10 times lower. And we can push this continuation down, so bear with me. It's equivalent. We have the result is always 55. Until we are at the point that is, hey, at least as far as I can see, is tail recursive. So, is tail recursive now? I can use recur. Is it true? Yes. The compiler is not complaining. It's not telling me that it's not in tail position. But if I try with a large number, I'm going Stack Overflow. How can it be? So progress so far. We are not swapping operands. It's tail recursive at least on the surface, but it's bombing on the stack. So it isn't. We confuse the Clojure compilers. Yeah, in some sense, we just push the recursion in another place. The compiler cannot fetch it, like find it where it is on the surface syntax. So a few more steps. Let's extract and apply cont, function up. It's not doing anything, we're just calling it. And we gradually pull up into this apply cont the core of the summing function, which is the if statement and summing, continuing summing up things. Until we arrive at a point where we have the accumulation of parameters. It's, so it's just explaining how it is done, but it's still equivalent. We just pulled up in an external function. We clean up a few things, and finally, yay, it's properly tail recursive. So we moved it up. Progress so far. Let's see, I have the bonus content, I cannot go in, but what we were able to achieve is, this is a version that is tail recursive proper, We have a trade-off that I couldn't go through in detail, but we are listing computations in a list, and we are pulling them up in the apply count function. So we are trading consuming the stack with creating a list. Conclusions, I cannot go through the rest because I think I'm out of time. This is how tail recursive optimization works in a very, 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 very simple way. It is how clojureCur work. We couldn't see that really, but bear with me. This is how continuations work. If you have ever heard what continuations are for, they are to do tail call optimizations automatically, hopefully. So the idea is treat Clojure like a high-level function, but transform it down to something that looks like assembly. When you have it in that form, you can use it to emit very low-level things like bytecode directly, or machine code, or CPU instructions. Clojure the ultimate imperative.